Apologize for that there. The Rugrats just came home and had to make sure that they were fed and watered. We're just going to finish off this PowerPoint here. We only have a couple more slides to go. Just change something up here. Just this whole idea of overloading, this parallel circuit. If you keep adding, like parallel circuit is this one right here, right? And if you think about it, your current is traveling through, current's going here, here, and here. But if I keep adding new things to it, in this scenario right here, there, National Lampoon's, there's a holiday picture there, very, very funny. But you see what's going on here. You see all these different plugs and wires all mishmashed in together. If you keep adding light bulbs, basically what you're doing metaphysically is you're increasing the size of the wire. Say you got a wire here, here, here. Let's say you have 1,000 lights in parallel circuit. Now you have 1,000 wires all doing and they're all working in unison. So if you keep adding, connecting more devices to the circuit, more pathways for the current result. Okay, makes sense, right? Current and resistance are inversely proportional, so this lowers the total resistance of the circuit because you keep adding new wires which are connecting there to light bulbs. So basically what you're doing is you're making a bigger wire, and if you're making a bigger wire, you're lowering the resistance. You remember there earlier on in the PowerPoint there, the smaller the wire, the smaller the resistance. Oh, sorry, the smaller the wire, the bigger the resistance. The bigger the wire, the smaller the resistance. So if you have all these light bulbs in parallel, there's really no resistance. And so you have massive amounts of current flowing through, and that's where you can get this overloading. Circuits that carry more than a safe amount of current are said to be overloaded. Connecting too many devices in the same parallel circuit can result in overheating, which can start a fire. Sorry, I just wanted to go through that because it is important. We did this example here. You guys can have a look at it. It's not too bad. It's just the understanding. I can ask you this question in a parallel circuit or a series circuit. The math will be a little different. Okay, in a series circuit, you won't have this. Where are we here? The current flowing in the first device plus the current in the second device plus the current in the third device plus the current in the fourth device will equal the current output of the total supply. Okay, of course it will. There is more than one path for the charges to follow. Okay, if one of the devices burns out or removed, the others are still good. Often the two types of circuits are combined. One switch may be in series with several light bulbs that are in parallel. Okay. As more devices are connected to the circuit, more pathways are created. And I wanted to reiterate this again because this is important of what's going on. Okay. Fuses. Very important. To prevent overloading in circuits, fuses are connected in series along the supply line. And what these fuses do, you see in this way there, the entire current passes through the fuse. And this is your safety. This is your safety net. The fuse is constructed with a wire ribbon. If it heats up and melts at a certain temperature, a certain current, and if it reaches that current or exceeds that current, the connection there will be stopped. If the fuse is rated for 20 amps, it will pass 20 amps and no more. A current above 20 amps will melt the ribbon and break the circuit. And that's how, it's a safety feature, right? These fuses, they're in there, and if there's too much current, choom, shuts the whole thing down. Brilliant, eh? Test yourself. What happens to the current in the other light bulbs if one bulb in a series burns out? They're all gone. What happens to the brightness of each light bulb in a series circuit when more bulbs are added to the circuit? Aha! Adding more lights will increase the resistance of the circuit. This will decrease the current in the circuit, and thus each lamp will dim. Okay? So each light bulb adds resistance, and if they're in series, okay, so the current is coming through right here. Here we go. So the current is coming through, and it hits here, and it slows down, and then it slows down even more, and then slows down, and then it slows down. You see what's going on here? And so that's that. Oh, sorry. What happened to the current in the other light bulbs if one bulb in a parallel circuit burns out? There, all the other ones are fine. What happens to the brightness of each light bulb in a parallel circuit? No change in a parallel circuit. I can keep adding light bulbs and my lights will still be the same brightness. In a circuit consisting of two lights connected in series, if the current in one lamp is 1 amp, what is the current in the other lamp? The electric current has but one pathway through a series circuit. The other lamp will be 1 amp. If 6 volts were passed across the circuit in the previous question, so series, and the voltage across the first lamp was 2 volts, what would be the voltage across the second lamp? Well, you can kind of see where this is going. 6 minus 2. The amount of energy given to the total current is equal to the sum of energies given to each device. Therefore, the voltage across the second lamp must be 4 volts. If the current through each of the 2 branches of a parallel circuit is the same, what does this tell you about the resistance in each of those 2 branches? Of course, they have to be equal. See, differences there all of your test material is here. I would recommend making notes, study notes, test notes, so you have them readily available. But same questions, different answers there for series and parallel. And as long as you have them ready at hand, there to do your assignment and all that, you guys should be fine. How does the total current through the branches of a parallel circuit compare with the current through the voltage source? How does the total current through the branches of a parallel circuit compare with the current through the voltage source? Okay, different things here. Talking about the battery and talking about through the parallel circuit itself. The total current in the circuit equals the sum of the currents in its parallel branches. So whatever's kicking out of the battery, you add them all up, it should total the same. Are household circuits normally wired in series or in parallel? Normally parallel. Okay, so we don't lose any of that brightness due to resistance, because the more things you have in a series circuit, the more resistance you have, so the more progressively dim your bulbs will get. Why will too many electrical devices operating at one time often blow a fuse? The same thing. You remember, most of the stuff there in the house is parallel. And if I keep adding things here, I've decreased the resistance because I'm making my wire bigger, which is decreasing the resistance, which will increase the current. So therefore, you will bust a fuse. Hopefully bust a fuse. Not anything worse. Yes, good. And here's the tail end. There's one last formula here. I think. Yes, there's only one. And again, it's another little triangle formula. P right here. Okay, power, current, and voltage. And you'll remember what power is. All right. the moving charges in electric current do work. Okay, remember work and power. Remember work is equal to force times distance. Here we have electrical work, which we have its own formula. But you can see there that we can have a correlation there between work and power. They can heat a circuit or turn a motor, for instance. The rate at which electric energy is converted into another form. That's your definition of power here, electrical power. And again, we're in watts. Okay. And a light bulb rated at 120 watts operating on a 120 volt line will draw a current of 1 amp. Plug your numbers in, play, next question. A 60 watt light bulb operating on a 120 volt line will draw a current of 0.5 amps. So it's just a matter of flipping these guys around, plugging and playing, okay? And here's some examples. I didn't even bother to put in how to because you're just using this formula right here. But be careful. You have a look. I want you to go through this, okay? And have a look at where are your connectors. Here I've got volts. Here I've got volts. I could ask you to find me an answer here, but you'd have to go through. I could give you resistance and current. You find volts. You'd have to sub them into here or something like this, right? So just take note of where all your doubles are. Here's current. Here's current. Here's current. Okay? Power. Power. Work. I think that's my only one for work. But just know, oh, there it is. Okay? So, yeah, there's your work is equal to force times distance. Now, because that's how this is going to work. I'm going to give you information for one formula. You're going to have to spit out an answer, sub that answer into another formula to give me what I'm looking for. Or I could be real nice and only make you use one, which I'll probably do, but guaranteed I will throw one or two out there to make you think. Okay? So you guys can read these and proofread them. I'm pretty sure they're correct. Okay? And that was a long PowerPoint. This one here, this is something else to have a look at. Look at all the words in here that I could throw onto a matching. Electric charge, conservation of charge, Amber effect, static electricity, fundamental charge, which we've seen. Okay, and there we go. Coulomb's law, polarization, you remember the wall? Electric field, positive and negative, the direction they... Electric potential energy, just another word for volts or battery. Electric current, I, measured in amperes. Semiconductor, silicon. Okay. Resistance, Ohm's law. A conductor, what is a conductor as opposed to what is an insulator? Oh, I know that one. Superconductor, what's the ideology behind that? Voltage, volt, potential difference, open closed circuits, series parallel fuse, electrical power, all these. These are just some of them. So have a look at all these. Your assignment is only on this week. Okay? So you guys have everything there you guys need, and the assignments there is due in 2 weeks. All right? Thanks, guys. Have a good one.